Alright, so in this video, we're going to discuss about inverse trigonometric functions. Alright, so what about inverse trigonometric functions? So basically, in some videos, we took sine inverse of something, right? Cosine inverse, tan inverse. So we're going to discuss those functions. So when we say sine inverse of x, this does not mean 1 over sine x, right? That is a very important point. So in trigonometry, when we say inverse, we do not mean 1 over sine of x, because 1 over sine of x is a different function. This is cosecant x, right? So it's a different function. So that is one thing you need to know. So sine of x, if you remember, is not a one-to-one function. And why is that? Well, if you remember, sine of 45 degrees is equal to sine of 135 degrees, which is 1 by root 2. And I'll leave you to... So this is, if you plug into your calculator, sine 45 and sine 135 is going to give you the same output, right? Or you can also give... So sine 45, so sine pi by 4 in radians is 1 by root 2. And sine 135, which is sine 3 pi by 4, is also the same, 1 by root 2, right? So that means that we have 45 degrees and 135 degrees, two inputs mapping to the same output. So it is actually a many-to-one function. So a many-to-one function cannot have an inverse. So how do we ensure that our sine of x has an inverse? We do the following. So this is true for all trigonometric functions, is that we perform a domain restriction. So we say that let y is equal to sine of x such that x is between negative pi by 2 to pi by 2. And let us look at the graph. All right. So, okay, something like this, right? So from, if let's say this is negative pi by 2, and let's say this is pi by 2. So sine of negative pi by 2, let's say this is 1, and this is 1, right? Sorry, it cannot be 1. Let's say this is 1, and this is 1, negative 1. All right, so something like this. All right. So sine of negative pi by 2 is 1, sine of 0 is 0, and sine of pi by 2 is positive 1. So the graph for this domain looks something like this. This is y is equal to sine of x for x in this domain. So this is the domain, restricted domain of x. And now if you look at this function, it is 1-to-1 because it's always increasing, right? So this is a 1-to-1 function. For if you, this passes the horizontal line test to check if a function is 1-to-1 or not, right? If you draw a horizontal line, it only intersects the curve at one point. So this is now 1-to-1. Restricted domain of x makes it 1-to-1. All right. So now, what is the range of this function? Well, range is, well, it goes as low as negative 1, and it goes up to positive 1, right? And domain, we discussed, was between negative pi over 2 to pi over 2. So now we can figure out an inverse for this graph. So let's say 1 is about here. So this is negative 1, this is positive 1. So we can draw the line y is equal to x. Roughly, we can draw the line y is equal to x. So y is equal to x would look something like this, although it's not up to scale. This blue line would be y is equal to x. All right, so now we just need to reflect this graph over this axis, right? And we can think about this. So for sine inverse of x, what is the domain? Well, that is the range, right? So the domain is actually negative 1 to 1. Range of your original function is the domain of your inverse function, right? So x is an element of -1 to 1. Range was -1 to 1, so now the domain is here. And what is the range? Your range is this, of sine inverse of x is going to be from -pi/2 to pi/2. All right, so now at -1, if you put -1, you are going to get pi over. At -1, you are going to get -pi/2, pi/2. So if you put sine inverse of -1, then, so if you remember, if sine of -pi/2 is equal to -1, then sine inverse of -1, the inverse function, should give you -pi/2. Right? Inverse function takes your output as your input and gives your input as your output. All right, so -1, you should be here. All right, and 0 gives you 0, and at pi/2, you should be up to, sorry, at 1, you should be up to here. So your graph looks something like this. The orange curve is the graph of sine inverse of x. And let me show you more clearly in this diagram. All right, so I believe, yeah, it's this one. So yeah, you can see this, right? You restrict your domain from this and your range here, and you get this domain and this range, and your graph looks something like this. So as drawn in orange. All right, and you do the same thing. All right, so let's make the inverse function for cosine of x. So cosine of x, we are going to restrict the domain from 0 to pi. The domain is going to be from 0 to pi. And the range is going to be from -1 to +1. All right. So what is the graph going to look like? Well, the graph looks something like this. So let's say this is pi/2 and this is pi. All right, so we start from 1, we go down to -1. So your graph looks something like this. This is the graph of cosine of x for that domain. All right, so now let's draw. So pi/2 is here, so 1 is somewhere here. I'm just speculating. Let's say 1 is somewhere. It's hard to figure out where 1 is to give an appropriate justification for where 1 is. Yeah, 1 is going to be somewhere here. Let's just say that. All right. And -1 is going to be somewhere here, right? So your graph, y is equal to x, is going to look something like this. I know it's a horrible scaling, but I think the drawing will come out fine. So now you have to draw cosine inverse of x. So it's going to be a reflection over that line, right? Over y over x. So cosine inverse of x is going to have the domain -1 to 1, which is the range here. And it's going to have the range 0 to pi, which is the domain. All right. So let's think about values. Cosine pi is equal to -1. So cosine inverse of -1 should give me pi. So -1, and I get up to pi. So let's say pi is here. So -1, I'm going up to pi, right? Cosine pi/2 is equal to 0. So cosine inverse of 0 is pi/2. So at 0, I am up around here at pi/2, right? And remember, cosine 0 is equal to 1. So cosine inverse of 1 is equal to 0. So my point is somewhere here, right? This is reflected, this gets reflected like this. All right, so now if you connect your points, your graph should look something like this. And this graph is the graph for cosine inverse of x. If you reflect this curve over this line, you should get the orange curve. All right, so that is going to be the graph for cosine inverse of x. And let's look at a more accurate diagram here. So this was pi by 2, if you remember. But yeah, it's going to look something like this. And it's the exact domain restriction and range restriction that we discussed. And that is how your curve looks like. All right, so finally, let's go with tan. So tan x is going to have the same restriction. We are going to, as sine x, so we are going to restrict it from pi by 2 to negative pi by 2 to pi by 2. And the range for this value is actually negative infinity to infinity. Because if you remember the graph of tan x, it's asymptotic, right? So let's just draw the graph of tan x. So the graph of tan x looks something like this, if you remember. Right? So now let's try to figure out for tan inverse of x. So the range for tan inverse of x, the domain becomes the range, right? So it's negative infinity to infinity. So it's actually defined for all real numbers. So you can put any real number here. And the range is just negative pi by 2 to pi by 2. That is the domain, right? So how does the graph look like? Well, the graph looks something like this. So you go up to pi by 2. Your vertical asymptote is going to become a horizontal asymptote and negative pi by 2. And this point stays the same. But your graph, if you reflect the graph, is going to look something like this. That is how your graph is going to look like. The orange curve is tan inverse of x. And if you want a better picture, here it is. Right? If you see, so I draw it on the same plot, but yeah, tan inverse of x. So you have your range. Because remember, it's not defined at negative pi over 2 to pi over 2. So that is why you can't have it equal. So yeah, it's the exact same domain and range restrictions. And now with this, we are going to discuss some questions. All right. So without using a calculator, write down in degrees the value of. So remember, the range of cosine inverse of x is from 0 to pi, right? For sine inverse of x is negative pi by 2 to pi by 2. And for tan inverse of x is open bracket, negative pi by 2 to pi by 2. So this is a closed bracket. This is an open bracket. All right. So what number? So you just want to think, when do I have 1? Well, you have 1 at 0, right? Cos 0 gives you 1. So if cos 0 gives you 1, then cosine inverse 1 should give you 0, right? So that is how we are going to approach these problems. All right. And you want to check if your output is within this range, which it is. All right, so your solution is 0. Now remember, sine what value? Pi by 6 is equal to half, right? So sine inverse of half is just going to be pi over 6. So it says in degrees. So pi over 6 is 30 degrees, right? And you want to check, is 30 degrees inside the range? So this is just 0 to 180 degrees for cosine. For sine, it's just negative 90 degrees to positive 90 degrees. Is it inside the range? Yes. And this is just negative 90 degrees to positive 90 degrees. All right. So is it inside the range pi by 6, 30 degrees? Yes. All right. So tan root 3. So you know that tan 60 degrees is equal to square root of 3. So tan inverse root 3 should give me 60 degrees. All right. So remember, if f of x is equal to y, f inverse of y should equal to x. That is what you need to remember. Another way to think about this is that if I take the inverse of both sides, then this is the identity, x. All right, provided that f of x is within the domain of f inverse of x, right? Provided f of x is a one-to-one function, essentially. All right, so I hope I can erase everything. So with that in mind, so I'm not going to write down the range and domain. I hope you're familiar with it. But yeah, so sine of what value gives, well, if you remember, sine of negative 90 degree gives me 1, negative 1, right? So sine inverse of negative 1. So remember, my input for sine, if I want an inverse function, can only be from negative 90 to positive 90. So sine inverse of negative 1 should give me negative 90 degrees. All right, tan inverse of negative root 3. That has to be negative 60 degrees, right? Because tan of negative 60 degrees, if I take tan both sides, then tan of tan inverse of root 3, so these will cancel out, negative root 3, and I get negative root 3 should be equal to tan negative 60 degrees, which it is, right? So my solution is negative 60 degrees. All right, and cosine inverse of negative, so what value is it going to be? So remember, cos of what value, and what value, this value has to be between 0 and 180 degrees, gives me negative 1 by root 2. So it's definitely in the second quadrant, right? So in the second quadrant, it's going to be 135 degrees. That should give me this value. And yeah, basically it's 135 degrees here. Because if I take cosine both sides, then I get negative cosine inverse and cosine will cancel out. And I get this value. So 135 degrees, negative 60 degrees, negative 90 degrees. I hope that made sense. So sine inverse of 0, 0, right? Tan inverse of 1, pi by 4. Because tan 45 is 1. So tan inverse of 1 is pi by 4. So what, another way to think about it is, what value, what angle? So sine of x gives me a value, and x is an angle. Sine inverse, we take a value inside, we should get an angle. And this angle should have the property that you take the sine of that angle and you get that value, right? So tan inverse of 1, that should be an angle. And if I take the tan of that angle, I should get 1. So it has to be pi over 4. Right, cosine inverse of 1 by square root of 2. So when do I get that? I get that at pi over 4, right? Cos pi over 4 is 1 by root 2. Tan inverse of this value. So let's think. This has to be negative. Remember, tan inverse can only give me answers from negative pi by 2 to pi by 2. So tan, that is the range, right? So tan negative 1 over root 3 has to be negative pi over 6, right? Because tan of negative pi over 6 gives me this value. So it has to be negative pi over 6. All right. Cosine inverse of negative half. So it has to be an angle, because remember, the angle, my angle theta, my cosine, when I take cosine of my angle, if I need to have an inverse, this x can only be between 0 and pi, right? So if I have a negative output, then my angle has to be in the second quadrant. So cosine of 135 degrees. 135 is 3 pi by 4. So that is your solution. Sorry, not. It has to be, I get half. When do I get half? Well, cosine 180 minus 30 degrees. Because cosine 60 is half, right? So this is negative half. If you solve this, so this is going to give you 2 pi by 3. 2 pi by 3 is your solution. All right. Because cosine of 120 degrees is negative half. So yeah, 2 pi by 3 has to be your solution. And f is sine inverse of this. So your angle theta has to be between negative pi over 2 to pi over 2. That is where your angle has to be. And when do you get root 3 by 2? You get it at sine. So minus sine, what value gives you root 3 over 2? Root 3 over 2 is at 60 degrees. And I can write this as sine of negative 60 degrees. So my solution is just negative 60 degrees. Negative 60 is just negative pi over 3. All right. So given that theta, so we have a cosine inverse function. So my theta has to be between pi and 0. And in this case, I can say that cosine of theta is 3 over 5, right? It should have this property. Cosine of theta should be equal to 3 over 5. So let me just draw an angle theta, and cosine of theta is just 3 over 5. And my opposite, if you use the Pythagorean theorem, you're going to get 4. So what is sine of theta using this triangle? Well, you're going to see it's 4 over 5. And if you need to square it, you get 16 over 25. So that is your solution here. And what is tan theta? Tan theta is 4 over 3. And if you square it, you get 16 over 9. So that is your solution, 16 over 25 and 16 over 9. So we're done with this. The function is defined for this domain. All right, so for sine, we need to find the range of f. All right, so we know that sine of x is always between -1 and +1. So what if I multiply by 3, right? Because I need to get 3 sine of something. If I multiply by 3, because I'm multiplying by a positive value, my inequality direction does not change. So I get this. And now I need to subtract 4. So I am going to get this expression, right? If I subtract 4. And this is my function. So my range is just going to be this. All right, so that is my range. And find f inverse of x. So we are the function is defined for this domain. So for that domain, it's going to be 1 to 1. So y is 3 sine x minus 4, right? So the regular process, y plus 4 is equal to 3 sine x. And sine x is equal to y plus 4 divided by 3. So x is sine inverse y plus 4 over 3. So basically, I can write it as f inverse of x is equal to sine inverse x plus 4 by 3. Basically, we did this when finding the inverse of a regular function, right? So that is just b. All right. So if you have sine of x and your x is between -pi by 2 to pi by 2 is equal to y, then sine inverse of y is going to be equal to x. All right. So I'm going to erase everything if that is okay. Question 5. So we are done with the first 4 questions. We have this function. So I'm not going to sketch the graph. I'm going to leave the graph sketching to you. And for this domain, cosine has an inverse. Remember that. All right. So explain why f has an inverse. Because f of x is 1 to 1. If you draw the graph, you're going to see that it is 1 to 1 for 0, x to pi. All right, that is why it has an inverse. And let's find the range first. So f of x, so cosine of x, is always going to be between -1 and 1. And I need to multiply by -2, right? Because I have -2 cosine of x. So that, if I multiply by -2, I need to flip the direction of my inequality. 1 times -2, right? So I get 2 is bigger than -2. All right. And now I need to add 4. So if I add 4, I get 6. 4 minus 2 cosine of x, and I get 2 here. So this is the range. So the range is just going to be 2 f of x to 6. So that is going to be the range of your function, right? Because the middle part, this is your f of x. So it's less than 6 and bigger than 2. All right, and find the equation of this inverse. Well, y is equal to 4 minus 2 cos of x. So y minus 4 is -2 cos of x. If I multiply by -1, 4 minus y is equal to 2 cos of x. Cos of x is 4 minus y divided by 2. X is cosine inverse of 4 minus y divided by 2. And therefore, f inverse of x is cosine inverse. And instead of y, I just need to write 4 minus x divided by 2. All right. and sketch the graph of f inverse. So I'm going to leave you, but this graph needs to be a reflection of f of x about y is equal to x. All right, so I'm going to leave you to draw it on your own. Maybe I can give you a very rough sketch. F of x for 0 to pi looks something like this. So if I put 0 here, I get 4 minus 2. So at 0, if I substitute 0 here, I am at 2. If I substitute pi by 2, then I am at 4. That makes no sense. I am at 4. So at 0, this is at pi by 2. And at pi, if I put pi here, I am at 6. All right. So my graph for f of x looks something like this. So this is what my f of x looks like. So now my y is equal to x is going to look something like this. All right, so that is a very bad line. But yeah, y is equal to x is going to look something like this. So if you reflect this, if you reflect your pink curve over this line, then you get something like, your graph looks something like this. That is a very poor drawing, but yeah, something like this. So this is going to be f inverse of x, and I encourage you to do it on a graph paper so you have like more accurate values to work with. All right, so it looks something like this. F inverse of x. Maybe not this much, but something like this. All right, that is better, I think. So that is how your f inverse and f are going to look like, but I encourage you to do it with more accurate grid paper. All right. All right, so question 6. You have this function, right? And it's defined for this domain. So if you recall, when we restricted from pi by 2, this was our original restriction, right? This gave us the minimum most value. Pi by 2 gave us the maximum most value, right? So now, let's think about this. If I plug in pi by 2 here, I get f of pi by 2 is going to be 5 minus sine 2 sine pi by 2. And that gives me 5 minus 2, because sine pi by 2 is 1. So that gives me 3. So a logical extension is that, hey, previously I was restricting from negative pi by 2 to pi by 2. But I can also restrict from pi by 2. I was restricting from a minimum point to a maximum point. But I can also restrict it from a maximum point. And this maximum point occurs where? This maximum point occurred at pi by 2, but I can also restrict it until a minimum point, right? I can also take this arm, because that is also 1 by 1. So when is sine negative 1? Well, at 3 pi by 2. So you can take p to be 3 pi by 2. So you get, this is the minimum most value of this function. And if you take 3 pi by 2, you get 5 minus 2 sine 3 pi by 2, which is 5 minus 2 sine 3 pi by 2 is negative 1, so you get 7. So that is the maximum most value of this function. So from pi by 2 to 3 pi by 2, that is also an acceptable restriction, actually. All right. So that is the largest value of p. And for this value of p, find f inverse of x and state the domain of x. All right. So for okay, so y from this equation, I just get 5 minus 2 sine of x So you just do the regular. Y minus 5 is minus 2 sine of x, or I can write 5 minus y is going to be 2 sine of x, right? If I multiply by negative 1 on both sides. Sine of x is 5 minus y divided by 2. X is sine inverse of 5 minus y divided by 2. So that is the equation of your inverse. And what is the domain? Well, it's going to be the range of this function for this domain. And we just figured that out. The range was from 3 to 7. So the domain is just going to be from 3. So x is bigger than or equal to 3 and less than or equal to 7, right? So the range of this function, f of x, we figured out is less than or equal to 7 when you place in the minimum value of sine x, and is bigger than or equal to 3 when you place in the maximum value of sine x. So that is going to be the domain of sine inverse of x. All right, that is question 6. And question 7. We have a function again for this domain. All right. And see, it's x over 2. So if it's x over 2, then this is actually going to be a valid restriction for an inverse function. All right. So find the range of f. So if you think about it, when you had cosine of x, you restricted from 0 to pi, right? But when you have cosine of half x, then basically that is the equivalent of multiplying your x coordinate by dividing your x coordinate by 1 by 2. That is just 2x. So if you do 2x, then your x can be, if you multiply all your x coordinates here by 2, then your x can be from 0 to 2 pi. So that is why this is a valid restriction for an inverse function. All right. So find the range. All right. So we know that cosine of x over 2, cosine of any angle is always going to be between negative 1 and 1. So if we multiply by positive 4, the inequality direction does not change. So I get this expression, and I need to subtract 5. And if I do that, I get this. So the range is basically negative 9 f of x to negative 1. All right. That is the range. And find f inverse of x and state its range. Well, the range is just going to be this domain. So it's just 0 to 2 pi. That is the range, right? 0, f inverse of x to 2 pi. It's just going to be the domain of f of x. And find f inverse of x. Well, you know that y is 4 cos x over 2 minus 5. So you know that y plus 5 divided by 4, I'm doing things quickly, is going to be cos of x over 2. And cosine inverse of y plus 5 over 4 is going to give me x over 2. And basically, x is 2 cos inverse y plus 5 over 4. And that gives me f inverse of x is going to be 2 cos inverse x plus 5 over 4. And we are done. That is the equation for f inverse of x. And we're done with this topic. All right.